use an appropriate test to show if the following series converges or diverges. So sigma of an, so in our case the general term an is given by cube root of n cubed plus 1 over 2n cubed plus 3n squared plus 2. And by the way, when n goes to infinity, the bottom is growing faster obviously from the top than the top, so it's going to go to 0. So no use of test for divergence. Okay, let's try to use one of the tests. Okay, let's write down the leading terms from the top and bottom and compare with a new series. Okay, let's take new series whose general term bn is, just take the leading, so n cubed square root of n cubed, so square root of n cubed over 2n cubed, which is same as n raised to 3 halves over 2n cubed, which is same as, let's bring this to the bottom, n same n 3, and when we bring this to the bottom, minus 3 half. 3 minus 3 halves is 3 halves, so 1 over n raised to 3 halves 2, or we can just take, or just without 2, this constant 1 over n raised to 3 halves. By the way, sigma 1 over n raised to 3 halves is a p series. It will be a p series with p equals 3 halves bigger than 1, so converges. So sigma bn converges. Okay, let's take the limit comparison test. Okay, now limit n goes to infinity of an over bn, that is an n cubed plus 1 divided by 2n cubed plus 3n squared plus 2 divided by bn. Bn is, we are just taking 1 over n 3 halves, so dividing means multiplying by its reciprocal, so n raised to 3 halves over 1. Now let's find this limit. Okay, though this is not a polynomial, but when n goes to infinity, the limit matters only on the leading terms. 2n cubed, just 2n cubed on the bottom. On the top we have the leading term is n cubed square root of n cubed, which is same as n raised to 3 halves times n raised to 3 halves, which is n cubed. It's like n raised to 3 halves times n raised to 3 halves, n and n, you add the exponent. 3 halves plus 3 halves is 6 halves, which is 3. Okay, and this limit is n cube cancel 1 half, which is positive and finite. Then by the limit comparison test, both series behave the same, and this series, p series with p bigger than 1 converges. The series with general term bn converges, so does this an. So let me write that conclusion. Since the series with bn, that is 1 over n raised to 3 halves, that's the square root of n cubed, is converges, okay, being a p series with p equals 3 halves bigger than 1. Okay, since this converges, by the limit comparison test, the given series with an, given series also converges. Okay, so the given series converges.